Welcome all of you to this video. In this video, we will learn about the combination of solids and different perspectives of three-dimensional shapes. In the previous class, we learned about flat shapes and solid shapes. Raghav's father gave him some shapes and asked him to identify them. Can you identify these figures for Raghav and tell them their names? Pause the video to try yourself and then match your answer. Perfect! These shapes are rectangle, cylinder, cuboid, cube, triangle, circle, square, sphere and cone. Now Raghav's father shows him some more figures and asks if he can tell the names of the shapes. Raghav tells us that this is a dumbbell. It is a hut and it is something like a warehouse.
Well done. But these are the names of these things. Let me tell you about
shapes of these things. If you look at this dumbbell carefully, you will know that it is made with the combination two spheres and a cylinder. Similarly, this hut is made of a combination of cone and a cylinder.
Raghav, now what can you tell about this warehouse?
Father, its lower part is a cylinder and the upper part hemisphere.
Well done. You have learned very quickly. Come. Now let me tell you another important fact related to shapes. If you look at this box from above, what do you see?
I only see rectangle when viewed from above.
And what do you see from the front?
Looking from the front, I see a square.
And from the side view?
Looking from the side, I again see a rectangle.
Well done. The view that we get when we see an object from above is called top view.
The view that we obtain
when we see the object from the front, it is called front view.
The view that we obtain
when we see the object from the side is called side view.
When we see solid objects or three-dimensional shapes from different views in this way, we call it different perspective of three-dimensional shapes.
I hope you have understood everything that we have just seen.
Yes, Father.
In this video today, we learned about different perspectives of shapes and three-dimensional shapes made by combining plane shapes. In the next video, we will see some examples based on these. Welcome all of you to this video. In the previous video, we learned about shapes made from the combination of two-dimensional shapes, different perspective of three-dimensional shapes. Today, we will see examples based on these. Maya keeps her jewelry in the box shown. Can you tell By which combination of shapes has this box been made? As we can see, the base of the box is cuboid. Well done. But what shape is this lid of the box? Well done. This is half a cylinder. That's why Maya's jewelry box is made of a combination of cuboid and half cylinder. Let us now see another example. Identify the top view of the given solid, the front view and the side view. As you can see, the front view is a rectangle. Can you tell the side view? Well done. The side view is a triangle. Now the question is, what will be the upper view? Perfect. Looking at it from above, we will see a view of two connected rectangles. Today we understood solid shapes with the help of examples.
You are all welcome in this video. In this video, we will learn mapping of the places around us today. Some children were talking about the layout of the class.
How good will it be if the
Carpets.
of the classroom are put in such a way that a blank space is created in the classroom?
The class will be open and clean. Can there be a space to put books in the corner of the classroom?
A corner for holding games, puzzles and board games can also be made.
That's when teachers come to class.
Hello kids. Guess who has come to meet you today? This is Sri Krishna Kumar. He's an architect. He will help you make your class more tailored to you. Kids, I will help you map your class. For this, we will first find the length, width and height of the class and each item kept in the class. With the help of these measurements, we will create a map from which we can estimate the location of the objects and the distance between them. This is because this map will be made according to a scale in which we will show distances by lines. To do this, we need the length and width of the floor and height of the room. To make a class map, we have to first set the scale.
What is a scale?
Scale. Writing down the actual distances in a ratio is called the scale for a map. The area of India is millions of square kilometers. In the map of India, millions of square kilometers are shown with the help of centimeters. Let's understand some important things related to scale. The same scale is applied to every length and width in the map. The scale helps to reduce the actual distance proportionally. If you pay attention to the given map, you will see that 1 centimeter has been used here for 500 centimeters. Let me tell you some more things related to the map. Colors are used to show objects clearly in the map. A color is used to represent the objects of a group. We have all seen maps of India, the world and other countries. With what color can we depict the sea, river, pond, etc.?
Water is shown in blue color.
The ground is mostly shown in green color and different colors are used to indicate different features.
Children, hope that you have understood the essential things related to the map. So why not try make a map for your class now?
We have also shown many things in the class map. If we highlight them using colors, the information in the map will become more clear.
Come, let's see what your map looks like after coloring. You can easily plan your class better by adapting the changes made in this map according to this class.
Similarly, maps of roads, provinces, cities, countries are also used for planning and management.
I hope that you have understood the method of map making and its nuances. See you. Bye.
In this video, we learned to mapping of the places around us. In the next video, we will see some examples based on this.
You are all welcome in this video. In the previous video, we learned to map.
Mapping of the places around us.
Today, we will see some examples based on mapping. The map shows the physical characteristics of a place. This graphical representation keeps important information which helps in finding answers to the questions. In the previous video, we learned to make and understand the map clearly. Let's look at the map and find answers to some questions. Example 1. While playing, Riya and Arun found a map. You can see that map on the screen. Many questions arose in his mind. Let us find his answers. Question: what does this map show? A. People walking on the road. B. House management. C. A path from park to home. This map shows the path from the park to someone's house. Question: which buildings are built on the way? A. Hospital. B. School. C. Zoo. A hospital is built on the way. Is the map made according to scale? A. Is made according to scale. B. Is not made according to scale. C. Don't need scale. You got this right. This map is made according to the scale. What is the scale of the given map? A. 1 centimeter equals 1 kilometer. B. 1 centimeter equals 100 meter. C. 1 centimeter equals 100 centimeter. As you can see here, the scale of the map is 1 centimeter equals 100 meter. How far is the house from the park? A. 7.8 kilometer. B. 4.5 kilometer. C. 2.4 kilometer. The house is 2.4 kilometer away from the park. What can be the address of my house? A. Plot number 4, Pali Road. B. Plot number 12, Sundarnagar. C. Flat number 8, Kamlanagar. Plot number 4, Pali Road is the address of my house. You should also try to draw the path between two places of your choice. Figure out the proportional distance using the appropriate scale. Ask your friends question related to this map. So children, did you see how much information is stored inside a map? I hope you will be able to extract information by reading maps. See you.
Welcome all of you to this video. In our previous video, we have learned to map our surrounding places. In this video, we will learn about polyhedron and its features. What do you understand by polyhedron? The groups of polygons that are joined to each other at the edges are called polyhedron. Each plane of a polyhedron is called a face. Can you tell the edges and the vertices of this polyhedron? Perfect. The edges are where the faces meet, and the points where the edges meet are called vertices. Let us now find the relation between the faces, edges, and vertices of a polyhedron with the help of an example. The teacher is conducting an activity for the children of class 8. She gives these polyhedrons to Raju, Monu, and Payal respectively. The number of faces, edges, and vertices are shown with F, E, and V respectively. Can you help Raju, Monu, and Payal fill this table? We start with the cube. As we can see, the cube has 6 faces, 12 edges, and 8 vertices. The sum of F and V is 14, and the sum of the edges and 2 is also 14. Let us now look at the octahedron. As we can see, the octahedron has 8 faces, 12 edges, and 6 vertices. Here also, we can see that the sum of F and V is 14, and the sum of E and 2 is also 14. Now, let's help Payal. As we can see, the pyramid has 4 faces, 6 edges, and 4 vertices. The sum of F and V is 8. The sum of E and 2 is also 8. Can you see any similarities? Well done. Here the sum of F and V and the sum of E and 2 is equal. This is true for all polyhedrons, which we call the Euler's formula, which is valid for all polyhedrons. You can check the Euler's formula by trying for other polyhedrons yourself. Now, let's learn about different types of polyhedrons. Do you remember convex and concave polygons? Based on this, can you tell whether the figure shown is a convex polyhedron or a concave polyhedron? Perfect. Since the line segments connecting any points inside this shape may also be outside the shape. Therefore, it is a concave polyhedron. Let us now discuss regular polyhedrons. If in a polyhedron all faces are congruent and regular, if the number of faces meeting on each vertex is equal, then the polyhedron is called a regular polyhedron. Now the question is the shown figure a regular polyhedron? As we can see that all the faces of the shape are congruent but not equilateral. Is the number of faces at each vertex equal? No. Let's see how. Number of faces on P equals 6. 3 faces forward and 3 faces backwards. Number of faces on Q equals 3. The number of faces on the vertices is not equal and the faces are not congruent. Therefore, This shape is not a regular polyhedron. Today, in this video, we learned features of polyhedron, Euler's formula. In the next video, we will understand some specific polyhedron prisms and pyramids. Welcome all of you to this video. We have understood the polyhedron and its properties in our previous video. In this video, we will understand some characteristics of polyhedron prisms and pyramids. Most people think of a prism. It looks something like this, but they do not know the exact definition of this. So let's start with the definition of prism. Prism is a 3D, means three-dimensional shape, whose base and upper end are congruent and parallel, and all side faces are parallelograms. Let's look at some of the shapes and understand prisms. Look at this three-dimensional shape here. Some lines are dotted here. These are lines that cannot be seen from this view. Look at the base and the top end of this shape. It is a long figure with base and upper ends. Now, let's give the base and top end of it a color like this. We can see that both the ends of this shape are triangles and its three side faces are rectangular, one in front, one at back, and one down. Let's look at the definition of prism once again. This says that the base and the upper end are congruent and parallel. The base and upper end of this shape are congruent and are parallel. Also, by definition, we know that all side faces are parallelograms. Side faces in this figure are parallelograms. That's why it is a triangular prism. Here is another three-dimensional shape. We can see that its base and upper ends are both rectangles, which are parallel to each other, and all its side faces are rectangles. This is called a rectangular prism. We also know it by the name of cuboid. If you notice, you will see that the prisms are named according to their base and upper end. As its ends are triangular, so it is a triangular prism. Its ends are rectangles, so it is a rectangular prism. Its ends are pentagon, therefore it is a pentagonal prism. Similarly, you can also identify the name of the prism according to the base and upper end of a prism. Is cylinder a prism? Let us discuss this. Its base and upper ends are circles and parallel to each other, but the ends of the cylinder are curved, that is, it is not a parallelogram. Therefore, it is not a prism. Now let's talk about the pyramid. What is a pyramid? On hearing the pyramid, one would probably remember the Pyramid of Egypt. But this is not the only type of pyramid. The Egyptian pyramids look something like this. It has 4 points, which we will write as A, B, C, and D. This solid has only one base, which is a triangle. It has 3 faces and all 3 are triangles. One on right, one left, and one back. It is a triangular pyramid because its base is a triangle. Here is another solid figure whose base is a square and all other faces are triangles. Can you see that there is a triangle on each side of the square? This solid is a square pyramid because its base is a square. So, how can we define a pyramid now? The pyramid is a solid figure with a polygonal base, and all other faces are triangles. Pyramids are classified according to their base. Remember that all the faces in a pyramid are triangles except the base. Today in this video, we learned to identify prism and pyramids. In the next video, we will see some examples based on them. Welcome all of you to this video. In the previous video, we studied the polyhedron and its properties. Today, we will see examples based on polyhedron. Mohini bought 2 boxes to keep her pencils from the market. Are both these boxes polyhedrons? As you can see, this box has curved edges. This box is not a polyhedron because its faces are not made up of a combination of flat polygons. Now, look at this second box. Is this a polyhedron? This box is made up of a combination of flat polygons. So, it is a polyhedron. But what kind of polyhedron is it? It has 9 faces, 14 vertices, and 21 edges. If we look closely, we will find that its base and end are made of congruent heptagons which are also parallel, and all lateral faces are rectangular. This polyhedron is an heptagonal prism. Let us now see another example. If a polyhedron has 12 vertices and 20 edges, can you tell the number of faces? Pause the video and try it yourself. Do you remember the formula that shows the relationship between the number of faces, edges, and vertices of a polyhedron? Perfect! In the previous video, we learned about the Euler's formula for polyhedrons. Here, the number of vertices, V, is 12 and the number of edges, E, is 20. And we have to find the value of F, the number of faces. By substituting the values of V and E in the Euler's formula, we get 10 as the value of F. So there are 10 faces in the polyhedron. Now, try to make such polyhedron by straws. In this video today, we saw an example based on the Euler's formula of polyhedron.